Hello, Algebra 1. Today we are talking about line of best fit and correlation. Sometimes when we're looking at a group of data points, there is not a line that perfectly fits all of the points. So today we're going to look at some multiple choice problems and determine which lines best fit the picture, and this is called the line of best fit. So here's how we choose the correct line of best fit. We are going to draw a line through the points, determine whether that line is going uphill or downhill, which will tell us whether it has a positive or negative slope. We'll cross out the options that have the wrong sign slope because those won't help us. And then we'll find our starting point or our y-intercept on our graph and determine which option has that correct starting point. And that should be it. All right, let's start by drawing a line through our points. It's not going to go through every dot, but you kind of want to go through the middle as much as you can. So something like this. My line is going downhill, so I'm going to get rid of options C and D because my line should have a negative slope. A and B both have a negative slope. Again, that number with X. And then finally, I'm going to look and find where my starting point is or my y-intercept. It's down here around -2, somewhere around there. So that would be letter A. Because letter B has a +2, we certainly do not go through that point up there. All right, so let's try it again. Draw your line through those dots, just kind of through the middle of them. And this time my line is going uphill, so I need to eliminate anything that has a negative slope, which will be A, that has a -2x, and D also has a -2x. All right, and now I'm going to look for my y-intercept, which is right about here, a 1. And that would be option C, because again, option B has a -1. Okay, our line isn't going through the negatives there. All right, last one of these. I'm going to draw my line. It's kind of horizontal, which is why we can see that we don't have any x's here. Horizontal lines are just y equals. And then we're just estimating where does it hit, right? Well, between 3 and 4 it looks like. So the best option is letter A. All right, so letter A it is. All right, so all this line of best fit stuff has to do with something called correlation. Correlation is a fancy way of talking about how things are related. So what would be the relationship between how much fast food someone eats and what their weight is? So basically, what we would usually say for most people is as your fast food intake goes up, okay, as you eat more fast food, your weight is probably going to increase as well, right? This is called positive correlation because as one variable goes up, so does the other. We can also represent positive correlation with a graph. A graph that shows positive correlation is actually one that just has a positive slope. So if we look at this example below, we see these dots here. They are going in an upward trend. So we would say we have a positive slope. And again, how do we know? Well, they're going uphill. Now there is a point off here kind of on its own. This is called an outlier. This is something you'll talk more about when you're a junior. Even though it doesn't follow the trend of the rest of the points, there's still a clear relationship between the majority of the points. So this would be someone who maybe like eats a ton of fast food but is still like doesn't gain any weight. That's not normal for most people. So that person is an outlier. Another type of correlation we have is called negative correlation. For example, what is the relationship between the temperature outside and the amount of layers that someone puts on? Well, for example, if the temperature is dropping, right, it's getting cold, the number of layers that you're going to wear is probably going to go up, right? You're going to put on a sweatshirt, you're going to put on a coat, you're going to put on a hat, you're going to have more layers. Whereas reverse, if the temperature is going up, right, it's getting hotter, the number of layers that you're going to have is probably going to go down. Maybe you're just wearing a tank top and some shorts, okay? You don't have that sweatshirt, you don't have that coat on anymore. So this is called negative correlation because as one amount increases, the other decreases. A graph that shows negative correlation is one that has a negative slope. All right, so here we can see that our dots are decreasing. This is a negative slope. And again, we know this because these dots are going downhill. That tells us we have negative correlation. All right, and finally, there's one last type of correlation, and that is actually no correlation. This is when two things are just not related in any way. So the relationship between how much money someone makes and their favorite sport, well, there is no relationship. You can make a lot of money and love football. You can make a little money and like football. These two things are not related in any way. All right, so the reason this is called no correlation is because there is no relationship between these two topics. A graph that shows no correlation is one that shows no pattern between its points. So we can see these dots here are all over. There's no pattern. People also like to say that it's all scattered about. So this tells you there's no relationship between the two topics being discussed. All right, so let's take a look at number 1, 2, and 3 and determine what type of correlation we have here. Number 1, you should notice they're just kind of all over the place, so this would be no correlation. Number 2, even though they start to even out, there's definitely a downward trend here, so this one would be a negative correlation. And number 3, even though you've got some points kind of off on their own, in general this is going uphill, so this one would be a positive correlation. All right, now we can also identify correlation based on some topics without a graph. So we're going to determine whether we have positive, negative, or no correlation between these topics. Number 1, your eye color versus your age. Is there any relationship between that? No. So this is a no correlation situation. Okay. What about the amount of hours you work versus the amount of money you make? Well, in most cases, the more hours you're working at your job, the more money you would make. See how both those arrows are going up? They're going the same direction. That tells us this is positive correlation. Amount of sleep you get versus the daily temperature. If you were living outside, this would probably have more of a relationship, but since we are living inside and you probably have your temperature that is being kept consistent from either an air conditioner maybe or a furnace, this is something that probably does not really affect us very much. So amount of sleep versus daily temperature, there's probably not a whole lot of correlation between those two topics. Amount of water in a barrel versus the time on a hot sunny day. So all right, think about this one. The longer that barrel stays out there, what's going to happen to the water? Well, it's going to start to evaporate, right? So the amount of water is going to go down. See how our arrows are going opposite directions? This means we have negative correlation. Okay, the amount of time you spend on school versus your grade on school. Again, there are always outliers, people that don't kind of follow this trend, but in general, the more time you spend on your work, the higher your grade will be. So this would be what we call positive correlation, because again, our arrows are going the same direction. Number of cars on a road versus the speed of the cars. Think about traffic, okay, or rush hour when you have a whole bunch of cars. When you have a whole bunch of cars on the road, you tend to just be not really moving anywhere. So speed would go down. Arrows are going opposite direction, so this would be negative correlation. All right, and finally, the time you spend working out versus the percent fat of your body. Well, let's say you're working out a whole bunch. What's going to happen to the percent fat of your body? Well, it's going to drop, right? It's going to go down. So again, arrows are going different directions. This would be a negative correlation. All right, we have two words here, which are words you may be familiar with from bio, interpolation and extrapolation. Interpolation means we're going to estimate within a data range. And extrapolation means we are going to estimate outside of a data range. So let's see what this really means for us. The amount of whole milk was consumed from the year 1980 to 1995 can be estimated using this equation right here. We are going to let X represent the number of years since 1980. This means that 1980 is going to be like our starting year. We're going to call that as 0, year 0. Estimate the amount of whole milk consumed in 1994. Did you use interpolation or extrapolation? Okay, so here's how we're going to do this. Our whole milk, the amount of whole milk that we have is Y. And it says X is representing years. All right, we want the year 1994. But 1980 is our starting year. So the first thing you need to determine is how many years have actually passed. We can do that by subtracting 1980 from 1994, and that is a total of 14 years. So all we're going to do is go ahead and plug 14 in for X, and then we will use our calculator to see what that gives us, which is a 70. Gallons. It didn't specify units, but I'm going to say it's gallons here. All right, so now did we use interpolation or extrapolation? Here's how we find this out. Our year is 1994. The year range that was given to us was 1980 to 1994. So we're going to check. 1994 is within this data range. Because it's within, this would be interpolation. Okay, interpolation, estimate within a data range. Okay, let's try another one. Estimate the amount of whole milk consumed in 1999. All right, so again, we are going to go ahead, we're going to plug our number in for X, but you're going to have to figure out what that number is first. We're not going ahead and plugging 1999 in. That would mean 1999 years since 1980, which it is not. So we have to subtract first. And again, we're subtracting 1980 because that's what they told us X was, the number of years since. That's going to be 19 years. That's the number we're plugging in for Y, or excuse me, in for X. So -5 times 19 plus 140. And that gives us 45 gallons. Okay, so now let's look. 1999, is that within 1980 to 1995, or is that outside of it? It is after 1995. That means we have used extrapolation. We are using a number outside a data range. Okay, so that's extrapolation. All right, let's try one more of these. Jerry's average points per basketball game from the year 2012 to 2020 can be estimated using this equation. This is our data range. That's how we're going to determine interpolation versus extrapolation. Here's our equation. And then X represents the number of years since 2012. That means 2012 is year 0. That's what we're comparing everything to. Estimate Jerry's points per game for 2019. Okay, first step, figure out how far 2019 and 2012 are from each other. And that's going to be 7 years. 7 is what we're going to plug in for X. So 0.20 times 7 plus 15. And that's 16.4 points. Okay, to determine whether we did interpolation or extrapolation, I'm going to look at my year 2019. 2019 is within this data range up here. It is between 2012 and 2020, so that means this is interpolation. All right, and now we're going to do 2010. Estimate Jerry's points per game for 2010. Did you use interpolation or extrapolation? This one is a little tricky actually, because 2012 to 2010, 2010 is before 2012. You can't put 2 because if you put 2, that means 2 years from 2012 would be 2014. Since 2010 is actually 2 years before 2012, we are actually plugging in a -2, 2 years before. Okay, that's a little unique here. So 0.20 times -2 plus 15, that gives us 14.6 points. Okay, and 2010, this is not a number in our data range, right? It's before that 2012. That means we're using extrapolation. All right, so that was interpolation, extrapolation, and correlation. Please let me know if you have any questions. Have a great day.